can see in the camera over there. This guy here, right here, it's been pretty sweet. I think what's it called? Mecanum tire? Mecanum wheels?
Mobius Mecanum.
Mobius Mecanum.
I was actually thinking that I think Mobius comes from the Mobius strip.
That's pretty nifty.
Yeah.
So either way, it's gonna be fun. They're really slick. So we're gonna get to using the Raspberry Pi, connect it with the circuitry we did before. Then we're gonna try to actually take that, connect it to the 12-volt DC motors, and see if we can get it to drive. Might not do any smart car drive today, but at least if we can get those wheels to turn, that'll be a huge success. So we're running that in Python. So any Python lovers out there, I think you'll like this. And yeah, so we're gonna get started pretty soon.
Not being around for the introduction, I'm just tidying some.
We'll probably do another intro once we just want to get the link a little bit, get some more people joining.
Yeah. Names and
I don't think we have any viewers as of yet. That's good, alright.
Alright. I'm just bringing up the YouTube instead.
I'm just gonna be back to streaming now. We had some technical difficulties, so let us know if it's not working for you. We're just gonna test to make sure it's all good.
It always starts with difficulties.
Yeah, it always starts with difficulties.
Alright.
So want to do the recap again?
Yeah, hi everybody. So today we're going to be attempting to drive, basically the final objective would be to get the car driving forward with the Raspberry Pi as the driving input. There's a few steps that we have to take to get there. That includes, basically we have to test the Raspberry Pi's ability to do PWM, and we'll go through some testing procedures. We have to solder some connections to the motors themselves so that we can bring them into the Raspberry Pi or into the motor drivers. We have to mount all the equipment onto the car in hopefully a reasonably organized format. Then we have to write some PWM scripts. The first script will be for one motor, and then the second script will be for all four motors, basically. And then hopefully the car will be able to drive in a forward direction. Unfortunately, I think we finally proved that our Raspberry Pi 3, which is the Raspberry Pi with the ability to connect to Wi-Fi, is failed. So I'm going to contact the manufacturer tonight and see if they have any troubleshooting techniques, but it sounds like we went through every possible one. And when we see that the 3.3 volt power output is not showing 3.3 volts, it sounds like that's actually the defining factor to say this is fried. So we'll see what happens there. Hopefully that'll be alright, but we can test everything with our Ethernet connected Raspberry Pi for now, and we'll see how it goes. Anyway, I'm going to move over to the desk, basically write out our plan of action. So basically today the plan of action is to first solder connections to motors. And I'll show you what I mean by that. So if you look in the motor itself, you can see that there's two small pins, one there for motor plus, one there for motor minus. Those two pins need to come out to the motor drivers.
showed on the last few streams. So we have to bring some wires through the body of the car to those motor drivers so that we can actually drive these motors forward. Yeah, so we're going to make a soldered connection to that. We have to write test scripts. Can't write test scripts for RPi PWM. And the way we're going to do that is basically we'll have a PWM pin and a ground pin. And we're going to connect to a resistor, probably 220 ohm resistor, an LED. And then that's a ground. So what that's going to do for us is instead of using a multimeter to determine whether or not this is changing, we're actually going to be able to see the LED change to dark. That'll give us the opportunity basically to keep our hands off the Raspberry Pi while things are happening. Yeah, and then the 220 ohm resistor, basically the purpose of that is to keep current low enough through the LED that it doesn't end up frying the LED. Yeah, if there's too much available current or too much available voltage without this voltage drop, basically there's too much energy going through the LED, and it'll get really bright for a short period of time and it'll turn off forever. So once we complete the test scripts, we are going to make physical connections. To the RPi motor driver to the motor. So with that, basically we'll give it the opportunity to drive. And the RPi script, like I said, is going to be a simple one. It's going to be make the wheels move forward, just to make sure that we have every component in our circuit operating as expected. We won't do anything crazy fancy today, but we'll just do a proof of concept that everything in the circuits work.
Switch it around this direction, then I can hold the camera this way.
Well, that's enough writing anyway.
Okay, cool.
Yeah. So let's get started. So maybe what we could do, I guess, do you want to be a part of soldering? Might as well.
Yeah, I'll give it a shot. Last time Todd was involved. So here's what we're using, doing soldering. So you can see this soldering iron, and we have this guy for cleaning. And maybe you can talk about what those elements are that we're cleaning off. Where is the actual solder?
I have some solder here somewhere in my tickle chest. Is that what Mr. Dressup called it? Tickle trunk.
Tickle trunk, that sounds right.
So we don't have a whole lot of solder left, but we do have some solder. I don't know a lot about soldering. I've done it before, but typically you use this material called flux with solder, and it basically helps it to mate with other metals. I'm not really sure the details, but nonetheless, this solder actually has flux embedded. Yeah, as one unit instead of using. Not sure if you have flux in here. Do you? You just have solder. Interesting. Fair enough. And basically, yeah, when you want to remove the actual solder, you just dip it in some metal so it scratches it off the tip. My soldering iron is filled with solder because I didn't have a piece of steel mesh to clean it up. So it just got messy in standard Lucas fashion. Okay, so let's we'll show you the materials that we're going to be using to solder to the motors. You might as well bring your chair over. Do it.
Yeah.
I'll let you do the soldering if you want.
You have to guide me along.
Absolutely. I'm not an expert. We're learning together.
Yep.
Is that plugged in?
Not yet. I can plug it in now.
Sure. Once it's plugged in, we just gotta be careful. The unfortunate thing about soldering irons is really they're just that. There's no on-off switch. On is plugged in, off is unplugged, and outside of that, it's just a hot piece of metal, and you have to be careful around them for sure. You can get more expensive soldering irons that do have the ability to be turned off, but that's not our way.
Hello, hopefully we're back. Let's go back here. So we had some technical difficulties again, but I think we're back on track.
Hopefully there wasn't anybody actually. Sucks too, because that's gonna hurt the editing. It's just like 2 videos.
Yeah, it's gonna be a little more cumbersome, but I think Twitch and YouTube might drop. I think so. I read something about that, but I haven't tested it before. Anyway, so we're back. Everyone, please join. We are currently getting the wires ready to be soldered to connect to the motors, the RC car.
Yeah, so we basically have 4. Is 4 enough? 1? Yeah. 4 red wires for the hot wires to the motors, and 4 green wires for the ground wires to the motors, or the negatives. So red will be positive and green will be negative. Just to keep things color coded, keep things nice. Move this guy out of the way. Yeah, I don't know if anybody missed the conversation about the Raspberry Pi. We bought a Raspberry Pi 3 as the capabilities of Wi-Fi communications, and unfortunately, Wi-Fi the Raspberry Pi 3 seems to have an issue. It booted once, and now it doesn't. Now it quite literally doesn't boot anymore. Went through some troubleshooting, reinstalled hardware several times. Repeated the initial conditions that actually did work well for us, and I think we're just at a point where it's no longer operable, and we'll contact the manufacturer and hopefully they'll be able to help us out. Just is what it is sometimes. The big defining factor to say that it's not working is that the Raspberry Pi, when you measure the GPI or the 3-volt output, it's not showing 3 volts. So that suggests that something internal is actually not properly anymore. Shorted, might have came loose somehow internally. I'm not really sure what the condition was, but whatever it was, that's the situation we're in, unfortunately. I need some of this soldering iron.
Is it? Stop sticking around.
Stay. It's fine. If anybody has questions at this time, feel free to ask away. Plan to do things, or how we've done things in the past, or how we come up with ideas, or anything along those lines, or just general questions about how things in the world work. Maybe we'll know how they work, or maybe you'll introduce a new question that's worth chatting in the next few minutes. I don't know how you're logged in.
I don't know.
Interesting. That's fine. You can be logged into mine all you want.
I don't like it.
Okay, wires are ready to be soldered. Soldering iron is hot. Wires are ready to be soldered.
Alright, let me come over there and let's make it happen.
Nice.
Let's make sure our stream is up.
Okay, so
I know how much you love two-step verification, so I'm just doing that.
oh man, two-step verification has gotten to a point. Like I was logging into Twilio earlier today, and my two-step verified Google when I was logging in with Google, and then two-step verified me with Twilio, which was logged in through Google, which two-stepped. Oh man, I was livid. I was getting to a point, and it didn't work the first time. That's what made it worse. So I two-step, I seven-step verified.
7. Yeah, because
7.
every step makes another step come up.
Oh, it was terrible.
It's recursive step verification.
Oh. I cut myself a little bit.
Oh no.
I poked myself. Wires are sharp.
It's a dangerous job, everyone.
So I'm thinking if we put a curl in it.
We should show that. This is great.
So I'm thinking, my thought here is basically to assist the physical connection, put a little curl in the wire so that it kind of loops around the actual connection point before we solder it, so it has a bit of a mechanical connection before the metal, before the solder is the only, so that the solder is not the only thing holding it on, so that if there are any forces in any direction, it has at least a fighting chance to hang on a little bit. So the green's going to be negative.
Green negative, red
Green
positive.
negative. So you're going to want to solder it to this. Thing about soldering is you actually don't touch the solder with the soldering iron. My understanding is you touch the metal, make the metal hot enough for the solder to melt onto the metal.
Touch the metal. So that would be like the copper there.
Try and heat up both the copper and the I'm assuming some sort of aluminum connection, which is bad. Interestingly enough, if we're talking about power systems, that aluminum to copper connection is not good.
Interesting.
Because it creates, since it has a difference in electromagnetic properties, it would actually create a what would you call that? A gradient of energy at that passing. One's more conductive than the other, so there's a gradient of energy there, and then over time that causes the copper to oxidize. And when the copper oxidizes, the connection between the two metals would become an oxidized layer, and oxidization is not actually conductive. So over time, copper and aluminum sitting together would lose their conductive ability.
All right.
Yeah.
Yep. So we have good copper wires, but this RC car could use some improvements.
Could use them.
And all right. How to tell if it's copper is just that color there. Oh, what's over there? So you can see that this is the copper wire. Okay. So that is looking hot.
I'm gonna super.
Yeah. Make sure you don't burn the house down and my hands fall off.
So take a look. At. Actually, no, that's fine. Just leave it. We'll leave it.
Yeah. Okay. This looks hot to me.
Oh, it is.
The guy who shouldn't be scissors is gonna do this. Alright, let's make it happen. Oh, wow, it's really hot.
Yeah, it's perfect. You can bring this closer if you want. It's probably better.
As long as I'm far away from the heat. Alright, so we got this guy here. We're gonna try to heat this element up, and then we want to put in the spool. Okay, cool. Well, that's fancy.
I'll set this up. Yeah.
Yeah. So what do you want to do? Do you want to keep it up?
I think that's well. It's up to you. I thought for me that might be easier, but if you think it's easier to attack,
No, you're right. Yeah.
Yeah.
Okay.
So good luck.
Get a needle.
Or do you want me to do the? the tight one, because that one's might be tricky.
Is that
It's
the
on
tight one?
inside. What's on the
Where's
inside?
the
This will
non-tight
probably
one?
be the easiest one.
Oh, I see. Okay, how about you do the tight ones to demonstrate, and I'll do the
If you want me to do that,
Let's
no
do
problem.
that.
No problem at all.
Yeah, let the experts, everyone.
Expert.
Expert.
I've soldered about 4 times in my life.
All right, I've watched soldering happen more than that, but that was with Todd and I.
Okay.
All right.
So I'm gonna try and get a good angle. No, the wire's pretty well mounted.
Actually, here, should maybe I shall get us a little close up. 1 sec, everyone. Alright, if you're able to see that. So you see it has the soldering iron on the connections. We have the wire is already looped around the connection, and we have the solder. You just took that away. Heating it up first, and then putting the solder on top of it to hopefully heat up the solder so that it falls off and sticks on top. Is that right?
Basically we're just trying to get the metal to reach the melting point of water. That is it. And we're trying to make sure that the metal that's sitting on a circuit does not reach the temperature that melts PCB plastic, which I think is like 580 degrees Celsius.
Wow.
So we're not getting up there.
Some fancy plastic.
Maybe it's Fahrenheit. That sounds hot.
That sounds hot, yeah.
Not quite there. Not quite there yet.
Oh, hot enough to smoke.
There it goes.
Hopefully everyone can see this.
Alright, so the solder actually just started melting.
Alright.
Reached our solder temperature, which is great.
Now, is it good when it's smoking, or what are your thoughts there?
That's just the solder melting. We actually should be wearing safety glasses. Don't try this at home.
God damn it. Excuse my language. Alright,
But that's okay.
this guy.
We'll get over it.
He's a big risk taker, let me tell you.
Yeah, risk. High risk situations.
Yeah.
Let's take a look at our connection, see how we did. First solder in probably a year. A scale of 1 to good, probably not. That.
That's alright. As long as it works.
Actually, yeah, that actually does look pretty good.
Yeah, not to toot your own horn or anything. Sorry, 1 sec, I need to...
Yep, that's a good soldered connection.
So how do you know it's a good solder connection?
Well, I basically am looking for any sort of gaps between the solder, the copper, and the aluminum connection point. To make sure that it's not that it allows me to, or that it doesn't allow me to pull it off. With the force, I mean, it wouldn't be absurd. Like if I gave it a good tug, it'll probably come loose. Solder's not going to hold it that well.
But I can drive this thing without worrying about it falling off midway.
This will not be our failure point.
Good.
We will have failure points, but this will not be it.
Oh yeah. What do you think is going to be the failure point?
Yeah, that's a good question. Let me think. My failure point would be the
Solder.
Raspberry Pi that's already
No, the
failed.
Raspberry Pi. We literally put it in, and now it's already toast. So I think that's a good point.
Good guess.
Yeah, that's fair. You could bet money on that.
So you can do the next one.
All right.
I'm going to give you the seat.
You guys excited? I'm excited. All right, wish me luck. Burn your hands doing soldering insurance, so we're going to find out how this goes.
So you're going to want to do the same thing. Grab a red one this time.
Just make sure the camera's all good.
Yeah. Can I half screen this?
Not that one. What do you need?
Well, I want to see.
I think it's slightly behind.
What a sentence. Which sentence would that be?
All right. So we have the soldering iron still. All right, pressure's on. Careful, please. You're gonna move the chat. Yeah, there we go.
Something to tug. Yeah, that's valid.
That is valid.
Okay, so we got this guy still.
Good to see you, Neon. Thanks for stopping in. Hey, Nacho, how are you?
All right, Nacho Kitty, we'll bring you up to speed very quickly. So we finally have the motor in the RC car. So that's right here. As you can see it here. So we have the nice cool wheels. On the back side, we have the 12-volt DC motors. These pieces don't have direct connections. So there's a port back here, but that's for the wheel encoder. Is that correct, Lucas?
Yes.
So that's for the wheel encoder. However, these ends are actually how we're going to power it. So that requires us soldering our copper wires, and that will be soldered between the one of our is it the buck converter, or what is these guys? Motor drivers.
Motor drivers.
Yeah. We're going to solder this cable. So Lucas has already done one of them. So we've connected it here, and I'm going to give soldering a shot. So wish me luck.
Luck.
All right.
I believe in you.
All right. Very good. Let's see how this goes. Okay, so first step, as Lucas was saying, is to heat up the... Oh, wait, I don't have a wire on this, dude. God dang it. Okay. Yeah.
You just sit it right on it.
Here. Let me shove it in there. All right, so first step is getting on the wire. And our color scheme is red to positive and green to negative. So the other thing we want to look for is looping it around. What direction did you pick? It's arbitrary. Just make sure you loop it. All right.
Just have a loop.
So just have a loop, and you're trying to make sure. So there's two objectives. One, you want to make sure that the on here so the connectivity is good, but you also want to give it enough solder. There's some strength to it. So this wire, as we're driving around, isn't going to be very easily just to tug off. So it helps by looping it around. Just a little loop. Hopefully everyone can see this. Stream is still good?
Stream's
All right.
good.
Okay, so we're going to loop that around.
I'd make it a tighter loop than that if you can.
So critical, this guy.
I don't want it to be the failure point.
He bet money that it wasn't going to be, so I gotta prove him wrong here, you know?
Mm-hmm.
How about this?
Let's take a look.
Yeah, that looks perfect.
There we go. But what should it...
I can hold it for you if it makes it easier, or you
How
can
did
use
you
your
get it
fancy.
to stay on there anyway?
I had a better loop than you do. But you can use this. This is what this is for. To hold it.
Yeah,
in
so
place.
this here, this right here, the things. You have nice little arms, and they move around. So it's pretty neat. But since Lucas didn't use that, I don't have to, right?
I might use it for the next one.
You did it once without training on the job. You haven't heard any customer complaints. Wait, what did you do? Soldering? Nacho Kitty? That's exciting. So it might be easy. Alright, well let's hope.
She is pretty much good at everything, though.
Yeah, that's fair. That's fair. I got some tough competition here. I got Luke, the experienced senior guy.
Senior guy.
And I got Nacho Kitty, who's good at everything, first try. So we got our work cut out for us. We got the dream team on the call. We got Neon Jawbreaker. Ow, ow, ow. Oh, I think this is hot already. Alright. I think it's because I tapped it earlier. Alright, so we have this. It's kind of staying still. I think that looks pretty good. Don't show Lucas. He's going to hate it. Alright. So I have...
Don't talk to the QA guy, 'cause he's going to tell you what you don't want to
The
hear.
QA guys right now would be like, what? This is what Glavin does at home? This guy, look at him. Look at him
Don't
go.
bother with the solder.
He don't bother us. Oh, right. Heat it up. Heat
Make
it
it
up.
nice and hot.
Is that good there? What
Try and touch both. Ideally, you can kind of get like a yes.
Yeah, all you're trying to do is get both of the metals to the temperature at which the solder melts. I'm not get they have thermometers
Wow. On the
Like-
tip?
on the bar. The whole bar kind of heats up pretty well equally. Whoa, on these $8,000 cameras because the main engineer didn't have time. I didn't work there. I don't work there, and I hear they're all discontinued, so maybe I did mess it up.
Maybe.
Oof.
Well, maybe next time we'll have you on the show and you can show us what you got.
Yeah, so I suppose while Glavin was giving you a little soldering adventure, I'll give you a rundown. I went through the rundown we're trying to accomplish today, but I'll do it again since we're all.
If you 4-finger swipe on that desktop.
Yep.
And then select the bottom left. Select one with the face.
That one? Oh.
Yeah, that one.
Yeah. Perfect. Okay. So now, so we have a new fancy toy. We have the ability to watch both of our cameras. Actually, we got a great camera for streaming.
It's an iPhone. Oh shit! Help me.
Do you want me to do it? You can do it. I believe in you. Fix it.
Dude.
Fix it. Don't ruin the motor.
Don't ruin the motor. We can buy another one, right? I don't like it. I don't like it.
So I'm trying to. So basically, what we're going to accomplish today is to get all 4 of the motors soldered, brought into the motor drivers. We're trying to have the Raspberry Pi tested such that it can give a PWM output to the motors, and then basically at the end of the stream, hopefully the car will be able to drive forward. Nothing more than that, but I think that's a pretty ambitious goal, and we're going to aim for it. The Raspberry Pi PWM, pulse width modulation, I'll give you a little rundown on that as well. Pulse width modulation is basically the idea that if you have a 5-volt supply, you can create voltages between 5 volts by changing the amount of time spent at 5 volts. For example, if half of 1 second it was spent at 0 volts and half of 1 second it was spent at 5 volts, that would suggest that it was a 2.5 volt source if you flash it on and off quick enough. And then you can, if it's on 60% of the time, then it would be 60% of 5 volts, whatever that number comes out to be. Yeah.
Don't judge me,
I guess
Lucas.
3 volts. Because. Anyway, so that's what we're trying to accomplish. We determined that the Raspberry Pi, or at least we determined that we do believe that the Raspberry Pi we bought with Wi-Fi connectivity has failed. Unfortunately, the internet. It looked like a what's the Raspberry Pi?
Having all day. It's great. My wire fell off. Lucas has come to the rescue. Pretty good over there, though. But let's go take a look.
Yeah, we're sorry about that, guys. But we're back. Glavin ingeniously used his support. Here, grab the camera, show it off if you'd like. Used his supporting system to hold the wire in place while he soldered it, and I think that's great. And I'm gonna follow suit with the next one. How did you do when you're soldering?
I haven't even started yet. I just got it all day.
Surprise, surprise! It's soldered.
Wait, what?
I soldered it.
Oh, okay. I was gonna say, did it magically solder itself? Yeah. So you can see here. So we got another solder. The best image stabilization, sorry for that. Yeah. So we're getting there one by one. You're still streaming?
Streaming, yeah.
Alright. Alright, so I think we have one motor. Now, do we want to test that one motor?
Yeah, let's just do everything with one motor.
Yeah.
That's a good idea.
Yeah, rather than doing them all and find out we did it backwards.
So let's go to the screen with this small and the code. Bring up the Raspberry Pi.
Alright. So, it's time to do some coding. Wait a second. Sorry, there's a little bit of a mess here. Okay, so we are logged in to our terminal. It's SSH'd into this particular Raspberry Pi. 1 second, I just want to make sure it's streaming properly. Yeah, it looks okay. Alright, I'm going to make this text a little bit bigger for everyone to see. Mammoth size now. But do let me know if it's too small, we can just crank it up. Alright, so we've already looked up how to do this motor PWM. Do you want to show how we did that, or just jive right in?
What I would
to show. Well, you could just explain the PWM code if you want.
Yeah, let's do that. But we do want to say to everyone that it is very helpful to go and review code online and to go Google things and look at Stack Overflow and solutions. You don't always have to code it right from your mind out and have it memorized. There's so much out there that you can't possibly know everything. And especially for us, we're learning for the first time, as many of you viewers. So let's learn this together. So let's go motor PWM. So in motor PWM, we have, I'll just open up here in the editor. Anyway. Okay. So once again, as last time, importing from Raspberry Pi our GPIO, and then we have other libraries like the timing and sleep library. That's going to allow us later timing information, and that's going to be pretty useful if you want to pause and wait for things. So you can say, hey, wait for 1 second and do some action if you want to, flicker a light, or in this case, we want to send timed signals to PWM. So in this case, our LED pin is 12. I think by LED, is that the one that's PWM for the motor?
Yeah, that's correct.
Okay.
So if you want to quickly go back to my screen,
Yep.
I'll show what we're trying to accomplish. So basically on the Raspberry Pi has a select few number of pins that, so all of these 40 pins that you see in a row here, there's, it starts at number 1 on the top left there.
Go widescreen. It doesn't fit in the screen very well.
Oh, sorry. Yeah, the top left is pin number 1, and then it goes 2 to the right and all the way down to 40 on the bottom right. So pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is PWM pin. And then this pin down here on 40 is the ground. What we're trying to do is show that PWM takes place at pin 12, and we're going to prove that by connecting an LED, and what we'll see darker as the code runs. It's just an easier solution than using a multimeter and trying to hold it in place. It's kind of like putting a test print screen or a test print in the middle of a loop in software. This is the hardware equivalent of that, just so that you can see it and quickly troubleshoot. So yeah, we should be able to see that PWM works on this light, and then once we've proven that, we'll make the physical connections to our motor drivers, and we'll try this PWM on one of the motors and see if it goes forward.
Do you want to move this into the main camera view?
Yeah. Let's sit it on the car.
I'll move this over here. Let me take that.
Nacho Kitty made an interesting comment after our last stream. She suggested that we may want to consider talking about some other topics outside of what we're working on while we're working on more monotonous tasks, or not talking about something specific to what we're doing. The best way I know how to do that would be to ask you guys what you talk about. What's interesting? Do you want to hear about renewable energies? Do we want to hear about how motors work? That's probably pretty lame. Do we want to hear about nuclear energy, or what other topics would be interesting to talk about, Glavin?
I should love talking about hydropower.
Hydropower? Not hydropower.
Hydraulics.
Hydraulics.
Right. Yeah.
Hydraulics are great.
You like windmills for power and hydraulics for
Power
for
transmission.
transfer.
Yes.
Yeah, transmission.
So that's an interesting question that I brought up with Nacho Kitty, unfortunately for her. I was trying. So when you think about energy transfer, all electrical energy is actually originates. All AC electrical energy
Originates in circular motion. So you have a generator that basically creates energy through circular motion. That generator puts that circular motion in the form of a sine wave down an electrical wire, and then it comes out the other side again through a motor. So it's circular motion down a wire through circular motion and exits at circular motion. Whereas hydraulics are actually a transfer of linear motion. So you don't need something spinning, you need something to fall from a height, or you need some sort of force, linear force, to make a hydraulic. Yes, exactly, Nacho Kitty. We absolutely were. So the question, what's it? So if you the object called an actuator is
Once again, hopefully everyone's fine. Please let me know if it's still not working for you. All right, so Lucas was talking about really cool stuff. So back over to Lucas.
Too bad.
You wanna come over here and finish what you're talking
Yeah,
about?
sure. Move my, unfortunately, not wheelie chair.
Yeah, next time we'll get a wheelchair next time.
Yeah. So what I was bringing up was I was on the point of actuators. Actuators are electronics versions of creating linear motion, but they're typically just made of a motor that spins, moving some gears, and those gears basically push a stick to create linear motion. But hydraulics have the opportunity to create linear motion of other means. An example of a method to create hydraulic energy linearly would be to drop a rock off a mountain that's sitting on a piston, and over time it depresses that piston to some distance, kilometers away, with a water pipe, basically.
Try to convert that potential energy
into kinetic, exactly. But the problem is rotational motion is a little bit easier to have continuous. It's really hard to make a continuous linear motion system. You can have a really long-lasting linear motion system, but then something has to happen to bring it back to the top. Same with, and I guess another example of that is pump storage facilities. So basically what they do is they're a hydro dam that has a big water basin. This water basin will flow down a hill through a turbine when energy is cheap, or when energy is expensive, but when energy is cheap, you pump it back up the hill. Which is an interesting.
Doing some energy arbitrage there.
Yeah, you're just trying to, because that's playing the fact that peak of energy is more expensive than just energy as a general consumable entity. It's more expensive to create gigawatt number 370 than gigawatt number 1, because our turbines are already capable of creating gigawatt number 1, but we have to turn them all on to get 370.
Yeah, and if you're lucky, you can use solar power, right? Just let
Solar.
the solar, again, solar's every day. Let it heat up the water, make it rain somewhere else, and just keep letting that circulate.
That's right.
So it's incredible. There's always different ways to transform energy. We're very fortunate. We just gotta harness them.
Anyway, on to bigger things. Glevin's code.
All right. Let's get coding. So, let me make this bigger again. Oh my god, it's so big. Alright. I don't understand why it's doing that. Okay. Alright, everyone, we should be able to see it now. So, back to the motor. I don't understand. I'm having a rough day, okay? I don't understand why everything hates me. Recover from that. Gosh, that's the worst.
I think you can handle
Okay.
the understanding of that code.
Hmm?
You can handle the explanation of that code.
Yeah,
sure.
this is fine. Okay, so like we said, we looked at the LED. So that's going to be an LED for the starters, but eventually we'll replace this with a. But hopefully it didn't cut it. The last talking point that Lucas had before we cut it last time was going over the pins on the Raspberry Pi. So we've identified that this is PWM pin 12. Alright, so we have some boilerplate stuff, so disabling warnings. We're setting the mode to board. That's how these pins are mapped. So in this case, we set it to board. That means 12 is how that works. We in a previous one of our videos, but we can dive into that again if anyone has any more questions. We are going to LED pin up as an output, so that's all good. And then we're creating this PWM instance, and that's in Python. That's something, some object or something that we're able to execute on, rather than always providing the context. If you had to say, go, I want this pin, and I want this frequency, and I want it to be at this value, if every time you had to reapply all values, you're just going to have a lot of code. So what we can do in code is create objects where you're giving this information, and you create what's called an instance, that single thing that exists, and then you can call stuff on that instance. So we have, that's probably a poor explanation, but we'll get better with these explanations as time goes on. So we have this pi PW, so this thing, and this already knows its LED pin and its frequency because we've given it to it in the beginning. So then when we make other calls below, say, hey, let's start. In this case, we're passing 0. So that's using some do. I think that's kind of like clean up. What is the start 0? Is that just setting it to 0 so there's no power to it?
That's correct.
Yeah. So we're just setting it to 0, no power. Yeah, and again, that's the same instance. So we have like a thing and start at 0 power. Now this while true, so some Python syntax here. The while is a loop, means it's going to repeatedly do a thing given some criteria. So in this case, the criteria, we're always trying to evaluate this here. So in this case, the criteria is true. So do this thing while this other statement is true. And the statement actually is really true. Effectively, it's what's called an infinite loop because it will always be continuing to run. So we'll dive more into that at later coding sessions. There's a for. So where a while loop is always be doing this thing as long as this conditional is true. The for loop is actually iterating over sequentially some items that are provided. So in this case, we have this duty, another instance, another variable that and we're looping over a range from 0 to 101 in step 1. And if I recall Python correctly, I'm pretty sure this value here, and I'll provide some comments. So range, it goes from start to end and then step. So the range, we go from 0 to 101 with a step of 1, so it's going 1, 0, 1, 2, 3, 4, 5, 6, etc. And I'm pretty sure the end is excluded. So what it ends up returning, this is the same as if you had something like this, 1, 2, 3, and then let's just pretend we had all of these, and then 100. But notice it doesn't actually include 101 because it's up to excluding that end value with the step of 1 in between. And we could do it something like this. If we were to put 10, for example, then it would look like 0, 20, and again go to 100. So that's something we'll get. There's more Python work. So now we have our PWM, change duty cycle. So again, I'm thinking duty is referring to the power. That's essentially what we're...
Duty cycle is the amount of time that the power is on. So I explained PWM as the amount of time that 0 volt is on, or it's at 0 volt or 5 volts. If the duty cycle, I think it's probably on a scale of 1 to 100, correct?
Correct. Yeah.
So the duty cycle is on a scale of 1 to 100 to 100%. And that's percent of time that it's on.
Percent of time that it's on. Okay. Great. So yeah, whether or not it's like on or cycling back and forth. Okay. So we're going to change the duty cycle again. We're going to loop over. So duty is inside what this is called a list or an array, depending on the language you're working with. So our duty variable here is going to be referencing 0, and then the second iteration, so the second time it goes through the loop, is going to be 1. Then the next time it's going to be 2, all the way up to 100. And we're going to this code here, passing down this duty value, and keep going up 0 to 100. That's all we're doing. We went over 100 in the duty.
Nacho said the one
The
is
one.
redundant.
Oh, in the range.
Yeah, it is. It's optional. Yeah.
Interesting.
Yeah,
I didn't know that.
Thanks, Dr. Kitty. Yeah, so if you get rid of this, the default value is 1. I think it's important for this demonstration that we be explicit, especially down below, because we are going to be doing it in reverse order. So let's say in this case, we want to be going 0 to 100. In the case below, it's the same idea. It's still a for loop, but we're going from 100 down. And again, it's excluding the end. So this case here, it is 100, so it's including the first, but excluding the end. So 100, 99, etc., and it's going down to 0. So you see that we do not have, in fact, the -1. That's the statement here. So we go up to 100, and we're sleeping. I think sleep, we could take a look at the documentation here, but the sleep method, I'm pretty sure, is in seconds, so that's why we're providing it a tenth or 100th of a second. And then this half of a second here. Oh, this is 10th of a second. What am I talking? 100th of a second. So 100th of a second. So let me just make a note here. Sorry, it's been a while since I've done Python. 1/100th.
Right, so seconds, yes.
Thank you. Yeah. Seconds.
That person.
All right. Good. And then half a second. Okay. Good. Changing, we're for every value, for this for loop, for every value of 0 through 100, we're going to be executing 2 lines of code, which is changing the duty value through that value, so it's going to be 0 to 100, and then we're going to pause for 100th of a second. And then after we do that all the way up to 100, we're going to pause for half a second, so it's very clear that we've reached the top, and then we're going to go backwards and go down. So we're going to escalate up, go down. And we're just going to do because it's a while loop that. So it will always be true. It will be an infinite loop.
So all of that translates in the real world to this light. To this light turning on slowly and turning off slowly and turning on slowly and turning off slowly. Because it's getting more power until it hits 100% and then less power until it hits 0% in a circle.
Python 3. Thank you. So it should be doing things.
So, here, I'm going to turn out this light. Light coming in.
Now you're talking. Actually, one sec. Just so it's very clear. There you go. So it's off. Boom. There we go. All right. So you can see it flickering.
So it looks like an alarming light. And that's probably pretty similar to how actual alarm lights work. It's very simple. That exact configuration with these wires, but instead we're going to connect them to these wires, and then we're going to actually use the Raspberry Pi to cause the motor driver to push the motors in the forward direction. So let's unplug this. I mounted it just so that it's a little easier. That's where the new Raspberry Pi is going to
Did
go.
you just plug the Pi?
Ah.
It's okay.
I like far away,
He does.
but I
But-
guess
All
that's
right.
what's more important.
So once that boots back up, we'll be able to. So while it's doing that, can we switch the wires so they're connected to the motor? If you want to give it a shot.
We have a bit of work ahead of us before we get to that point.
Right directly to the motors, can we?
We have to connect all of this stuff.
All right.
Um,
So let's. Oh, sorry. Everyone's probably seen my butt. All right. Let me switch over to the. Right here. So let's take.
So we have to figure out how we want to actually mount all this. I'm thinking something along the lines of one motor driver, maybe here, and the other one here, something like that.
How symmetrical can we make this?
Yeah, we need the big holes so stuff can come
Especially
up.
since this, like this, we probably want to be centered because, or I guess this thing can move. But
Yeah, that can move, but I definitely want these holes open for stuff to come up through. That's okay. We don't need to worry about it right now. I think what we'll end up having to do is disconnect it here, mounting it, and then rewiring it based on where it's mounted. That makes sense.
yeah, it's fine.
For now. It's fine for now. Natural Glavin fashion.
All right.
Okay, so and make these physical connections to the motor. I need this, and I need positive.
So we're again connecting the motor, DC motor, to the motor driver.
That is
Positive's red.
correct.
And that's because the Raspberry Pi deals in 5 volts, and our motors deal in 12, and we don't want them to kind of have their wires crossed, so we put a motor driver in between. Make sure everything's safe.
The motor driver basically gives us the ability to bring an additional power supply into the motor. So both devices are powered from separate supplies in a sense. They both come from the battery, but one of them comes from a 5-volt supply that's stripped off the battery. So this device, we talked about this. What this does is it takes in 12 volts and outputs 5 volts. So this actually gives us the opportunity to power the Raspberry Pi with 5 volts while powering the motor drivers with 12 volts. Motor drivers give us the ability to change directions and basically change directions and change the speeds of the motors with the PWM. So with the same theory that you saw with the LED getting more power and less power, we'll get more power and less power with PWM on the motor driving capabilities. So all I have to do now is connect these two wires to in 3 and in 4. Basically what we've done here on this little motor driver is now we have a connection from the Raspberry Pi. So this is going to be a changing voltage from 0 to 1, or from 0 to 5 volts, and this is going to be 0 volts. So with this being 0 to 5 volts and this being 0 volts, the motor should go in one direction and it should change speeds over time. So we should see it speed up, slow down, speed up, slow down. And these are the physical 12-volt connections. So we'll actually have to connect our 12-volt battery to this to supply the motor driver to inevitably the motor. Is that Python script running?
Not right now.
Okay.
It helped to unplug the power, so it killed it.
Oh, cool. Alright, I'm ready for you.
Alright. Do we still have... So it is all wired in. Alright, do you want to pick it up?
Yeah, so this is the motor that's going to run. This is the only motor that's going to run. Hopefully it runs.
Alright.
Moment of truth.
I'm very excited. This is great. Alright, so going back to here, Python 3, motor, PWM.
Part of me isn't quite sure if this is going to work. Part of me isn't sure that this is going to do the speed up, slow down, because there might be a cutoff. The motor might actually end up stopping somewhere through.
Alright, you ready for this?
I'm ready.
3, 2, 1. It's meant to be doing things.
Oh no. Oh no. Oh no, 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 no.
Alright, killing it. Any chance we could have the light as well?
Have the light well. Okay, let's go back and let's just run it again.
Go and plug the Pi.
Let's just run it again and make sure it's running. Go run the script again.
Then we have power hooked up. Oh yeah, we're good.
Hit it. Yeah, that's working. Okay, let's try it without the PWM. Let's see if we can just get it to run with 5 volts. Straight up. So you had a second script, you had another script that was just turn the thing on.
Yeah.
I think it was called motor.py and mine's called motor.pwm.py.
Yeah. Alright, so let's go back to...
Womp womp is right, Nacho Kitty. Not all that surprised, we just went for it.
Alright, so this script here, we have our motor pin. In this case, it's 11. You want to switch it from 11 to something else?
12.
1.
Or 13. The code that were previously with the LED is 13.
Oh, it's 13. Okay,
Do
13.
we want 13? This old code here is not PWM. It
That's
is.
fine. PWM pins can be used for regular binary, but binary pins cannot be used for PWM.
Okay. So we got here. We're gonna set it to high. So get ready to hold. We're going to wait for 20 seconds. And then we're going to print done and clean these things up.
We haven't tested these motors. Where our big issue is right now. These motors might not work.
Are you ready?
I'm ready.
Are you holding? Is it just the light or what?
Just the light.
Okay. Is it working?
No.
Motor pin 13. Maybe.
4, 6, 8.
Oh, it is 12. Sorry.
Yeah. Usually am, but then I allow second guessing.
This channel's already in use. Is it doing the thing? I think it's on.
Yeah, it's on. Okay,
Alright.
great. Turn it off and then we'll try it again.
It should be off in theory. Oh, is it not turning off?
It's fine.
Is it fine? I don't want to kill the script though.
You run. Why must I cry? Why must I cry? Why must I cry? Why must I cry? Why?
Alright, let's see if we can get a voltage reading and see what's going on in there. This happy little environment. So, we're testing.
Back. Let's hope back. But at this rate, it is unlikely. So we're just going to keep restarting the stream. Alright. Let's go back here.
Yeah, we can't even get this alone our car.
Yeah. Womp Womp is right.
Is it running?
It only runs for 20 seconds. Alright, it's running now. Should we thing out of those wires?
Seeing nothing there. Okay.
Alright, rubber duck with me. So what do we have hooked up right now?
Let's, what we're gonna do.
So if we stay back. Oh no, my is disconnected. Gotta love these technical difficulties. 1 second, we get that phone fixed up.
Okay. We're gonna go back a step.